Hi, welcome back. Let's take a look at rotations. We are on page 312. Rotations. So a rotation is a transformation that turns your figure about a fixed point, and that fixed point is called the center of rotation. So we're going to be turning our figure. We're going to rotate it. The angle of rotation is the number of degrees that the figure is rotated. Okay, so now there's two different ways that you can rotate. You can turn a figure. You can turn a figure clockwise. So that's with the clock. That's with the clock. So that's turning right, turning your figure right. Or you can turn your figure counterclockwise. That's against the clock. So that means turning left. So you can turn your figure clockwise to the right or counterclockwise to the left. You can turn your figure several different degrees. One would be 90 degrees. So now this is your x-axis, this is your y-axis. So if you make one turn to the next axis, that's 90 degrees. So another turn, one more turn, the next axis would be another 90 degrees, so that's 180. One turn is 90 plus another 90 would be 180. That's halfway around your circle. So one turn is 90, two turns is 180 degrees, three turns is 270 degrees, and then four turns you're right back where you started. Okay, so again, one turn left counterclockwise would be 90, two turns left would be 180, three turns left would be 270, and then right back where you started would be 360 all the way around. Okay, so now turning 180 degrees, if you rotate 180 degrees, that's halfway around. So you could actually rotate clockwise to the right or counterclockwise, and you're still going to end up in the same spot, halfway around. Okay, so again, this is just showing you that one turn is 90 degrees, two turns is 180, three turns is 270. Okay, all right, so let's actually take a look at one. Look at number 6 on page 313. Look at number 6. Okay, so this says, what is the angle of rotation about the origin that maps triangle PQR to triangle PQR prime? So what is the angle of rotation? Meaning, how many degrees was it rotated? Okay, so now remember, we always start with our pre-image, the one that does not have the prime symbols. So that's this one. This is your starting figure. Okay, so it looks like we might be able to turn one turn. So it looks like if we start with the blue one and we make one turn counterclockwise to the left, that would be 90 degrees counterclockwise. So if it starts here and it's one turn, so that looks like 90 degrees. Well, let's check it. So one way that you can figure that out is by doing an L-shaped pattern between the points. Okay, so basically, if we start with this one and we figure out an L-shaped pattern starting with your center of rotation. So if we go over 3 units and out 3 units, over 3 units on this axis and out 3 units, see that L-shaped pattern we're creating? Over 3 units, out 3 units. Okay, let's make one turn left and recreate that here. Over 3 units, out 3 units. So P landed on P prime with the same L-shaped pattern. Okay, let's look at Q. If we go over 5 units, out 3 units, over 5 units, out 3 units to make that L-shaped pattern, over 5, out 3, let's make one turn left and recreate that same L-shaped pattern. Over 5 units, out 3 units. Over 5 units, out 3 units. So Q will land on Q prime up here. Let's try R. So if we go over 5 units and out 7 units, over 5, out 7 for that L-shaped pattern, over 5, out 7, make one turn left and go over 5, out 7, and you'll find R prime. So the angle of rotation was 90 degrees counterclockwise. Or if we actually turn clockwise, we would make 1, 2, 3 turns to the right. So 90 degrees counterclockwise would be the same as 270 degrees clockwise, the other direction. Okay, so let's actually look at number 8 right below that and try to rotate. This says triangle PQR is rotated 270 degrees about the origin. Graph and label the coordinates of PQR prime. So let's rotate it 270 degrees about the origin. Okay, so now it does not tell you which way to rotate it. So if it doesn't tell you, always go counterclockwise. If it doesn't say which direction, always go counterclockwise. So we're gonna go 270 left. So that means if we start here and we go 1, 2, 3 turns left, it's gonna land down here in this quadrant. Okay, so again, 1, 2, 3 turns left, it's gonna land down here in this quadrant. Okay, so let's create that L-shaped pattern. So if I start on this this axis, and I create the L-shaped pattern for point P, and I go over 1, 2, 3 units and out 2, over 1, 2, 3 units and out 2, then I'm going to do 1, 2, 3. I'm going to recreate that here. Over 3 units, out 2. I went over 3, out 2. I'm going to go over 3, out 2. This is where P prime would land. Okay, let's do it for R. I go over 7, out 2 units. I'm creating this L-shaped pattern. Over 7, out 2 units. I'm going to make 1, 2, 3 turns, and I'm going to recreate that here. Over 7, out 2 units. This would be R prime. Okay, and let's do Q. We're going to go over 6, out 1, 2, 3, 4 units. Over 6, out 4. I'm going to make 1, 2, 3 turns to the left and move over 6, out 4 units. Over 6, out 4. This would be Q prime. Okay, so that was a 270-degree counterclockwise rotation, 3 turns left. Okay, let's try one more of those. Take a look at number 11 on the back. Let's rotate 270 degrees about the origin. Again, it does not tell us which direction, so we are going to go counterclockwise. Okay, so now that means 3 turns left. So if we start here and we turn 1, 2, 3 turns left, it's going to land up here in this quadrant. So let's create this L-shaped pattern for K. I'm going to start on this axis right here. So if I go over 2, out 1, 2, 3,